The figure below shows a dartboard with a radius 9. They're talking about the entire dartboard. So allow me to place that dimension on the dartboard. Radius, distance from the center to the edge. Each of the concentric circles, there are 1, 2, 3 concentric circles here, concentric with the same center. They all share this center. Each of the concentric circles has a radius 3 less than the next larger circle. Alright, so from the center to the edge of the white circle is 3 less than from the center to the edge of this large gray circle. So this radius is 6, and the radius of the small gray circle is 3 less than that. So 3. If 24 darts land randomly on the target, the target being anywhere on the dartboard. In other words, your darts don't hit the wall like mine do when I play darts. How many darts will be expected to land in the shaded regions? So we want probability shaded. That's going to equal area shaded compared to area total. Because for probability it's favorable outcomes to possible outcomes. And the area of the entire target, the entire dartboard, represents all of the possible outcomes, the total possible amount of two-dimensional space where my dart can land. And the area of the gray rings, or this small gray circle and this outer gray ring, is called an annulus. Can't remember if there's 2 ends, but a donut shape, a flat 2D donut. The sum of those 2 gray areas, the small gray circle and this annulus, will represent our favorable outcomes. Our total two-dimensional space that represents favorable outcomes landing in the gray. Okay, I'm having a weird. I might be over-explaining. I hope you bear with me. I'm sorry. The area total is easy. Let's do area total first. It's the area of the whole circle, the whole big circle. Pi r squared for a circle. So the total area is pi multiplied by, well, they've told us our radius is 9. Pi times 9 squared, aka 81 pi. Do not substitute an estimate for pi. You make your life so hard. It's a ratio. Our pi's are going to cancel when we put it in the probability formula. The area shaded is a bit tougher. Let me think how. Alright, I know what to do. Let's find area of the white 2D donut annulus. That's going to be pi times 6 squared minus pi times 3 squared. In other words, I'm finding this circle and then I'm subtracting this circle to find the total white area. I think that makes sense. So 36 pi minus 9 pi is 27 pi. Now, the total area shaded will equal the total area, which we've already found, minus the white area. In other words, I don't need to calculate the area of this gray ring, this gray annulus, and add it to the gray circle. It's easier to act as if the whole big dartboard was all gray, because we've already found that would be 81 pi, and subtract away the white area, the white ring, because we've already found that is 27 pi. So 81 pi minus 27 pi is 54 pi. Alright, now we're ready to substitute into this ratio. I sadly have not left much room, but 54 pi over 81 pi. See how the pi's cancel? And then we have 54 over 81 of a large common factor is 9. 54 is 6 nines. Why am I drawing a blank? It's getting late. Yeah, 9 times 6 is 54. Oh my gosh, what is wrong with me? 10 6 is 60. Oh, I'm worried about the upcoming problems. 81 is 9 nines. See, I had a feeling there was a greater common factor than 9. The 18 was greater. Okay, divide that by 3, I get 2. Divide 9 by 3, I get 3. And this whole probability simplifies to 2/3. And then I looked over at the answer choices and I scared myself because I haven't answered the question. I found the probability I need to answer the question because if there's a 2/3 probability that the dart lands in the shaded area and I throw 24 darts, 2/3 of those 24 darts should land in the shaded area. 2/3 times 24. A third of 24 is 8. 2/3 of 24 must be 16. 16 is the answer. I'm going to resist the urge to go through this entire video and edit out any weird moments of mine, and I'll just hope that they're humorous and not scary. Number 5.